So now we got this example. So we need to solve this and using the principle of we need first to find the transfer function and then solve for v out. Okay, this is one example that we can go and apply what we just learned. Okay, so let's see. This is where we have z1. This is where we got z2, and also the sign is negative. And for the transfer function, it's gonna be vo over v in, which will be equal to negative because of the sign, the inverter pin. Okay, so it's gonna be z2 over z1. And whenever we have something like this, we usually write it in this form: z2 times 1 over z1. Okay, so we're going to represent them in the correct way. Okay, so it's gonna be negative z2 times z1. It's gonna be a fraction. So let's define what we have inside the z2. Okay, and let's see what we have into z1. Okay, I think the easiest one is z1. Let's go with z1. So the equation for z1, since we're working with r for z1, so this is what we're going to write there in that into that block. So it's gonna be I is times r. Now the problem is now for this block, since the resistor and the capacitor, they are in parallel, so we need first to find the, so we're going to work with this two equation, but we need to write them in parallel. So meaning we're going to have ls in parallel with 1 over cs is. Okay, so what you see here, so we're going to have, this one is the representation for, okay, sorry, I think I made a mistake. I was supposed to write r, not l. So it's gonna be we're going to have the capacitor is in parallel with the resistor. That's what you see here. So the capacitor in parallel with the resistor. So the way that we're going to write this equation, it's gonna be in this form. So first, capacitor, which is 1 over cs is in parallel with the resistor. Okay, so we're going to get the parallel equation of these two, but since, just to make it simple, we always cancel the current, since the current is common in all the equation. Okay, so I'm going to write them without the current just to make it easier for us to calculate, because even if we keep the current, later on we're going to remove it as we did with all other equations. So what I'm going to write it just in a simple way, so then we can work it out. The negative 1 cs parallel to r times 1 over r. Okay, and how do we solve parallel equation? So when tooth a and b are in parallel, it's the same as a times b over a minus b. So we're going to apply this formula. So it's gonna be something like this: v0 over v in negative So we're going to assume that we're going to multiply 1 over CS times R. 1 over CS plus R times 1 over R. Okay, just to keep it clean and proper, I'm going to solve it here. So we got 1 over CS. So I can even just copy the whole section so that I can solve it separately and then bring it back there. So trying to solve this one. So I'm gonna copy this one here so I can solve it. So it's gonna be this one multiplied by this one. It's gonna be like 1 over CS times R over 1. And down there we need to find the common denominator. But before we do that, I'm gonna go just step by step. So it's gonna be something like this. So it's gonna be so we're going to have 1 here. So here we need to write down the common denominator. So we assume that when there's a number or anything without, we assume that there's a 1 at the bottom. So a fraction times another fraction, we're going just to multiply the numerator together. So it's gonna be 1 times R. It's gonna be CS times 1. Okay, for this one it's gonna be, we need to find the common denominator. It's gonna be CS. CS is the common denominator. CS divided by CS times 1 is gonna give me, CS divided by CS is gonna give me 1. 1 times 1 is gonna give me, so we're going to have 1 times 1 plus CS divided by 1 times R. Okay, so it's gonna give me R CS. Okay, so we can even simplify it, then we're gonna go back to this equation. So it's gonna be CS times 1. It's gonna be CS divided by 1 times R. That's what you see here. Okay, and then the equation is gonna be something like this. Then what I'm gonna do, I'm going just to copy that section because I feel like it's gonna be just extra work if I just rewrite the whole thing. Let's just keep it the way it is. Okay. Let me just make some space before I continue because I feel like I'm running out of room, out of space. So I can even move this one. Okay. Okay, even there, I think I'm gonna have space. Okay, so I'm gonna put it like this. Maybe move this one on top there, so then I can only focus on what I have to do now. So I got this equation, and I can copy this one. Okay, so then I got this one. I can just continue by solving. So it's gonna be something like this. 1 times R, it's gonna give me R. This one's gonna give me CS. 1 times 1 is gonna give me 1 plus R CS. It's gonna be CS. And with fraction there's this rules. Okay, let me just make it short so then I can I can move it. So with fraction, there is this rule of saying that when we have two fractions, okay, what we do is you take the first fraction, you multiply with the second fraction. So I'm gonna get something like this. So you keep the fraction the way it is, the first one, but the second one you reverse it. So you're gonna v cs 1 plus rcs. Okay, so meaning you're going to reverse this fraction, you're going to reverse it. Okay, so once you get the fraction that you see this side, so then you're gonna get the fraction is gonna be something like this: r times cs, and then you're gonna have cs 1 plus rcs, which is gonna give you rcs over cs, because you're going to multiply this one by 1 and also multiply it by the one that you see there. So it's gonna give you rcs plus rc square s square. Okay, and if you don't want to do all of this, there's a way for you to simplify them. Okay, so I didn't see it, so there's actually a way for us not to get this far. You can actually simplify them. So if you want to simplify this, then from here you can just cancel out these two. Okay, then you will get something like this: r over 1 plus rcs. Okay, so this block here is gonna be equal to negative, we're going to replace with what we got, r 1 plus rcs times 1r. Okay, so this is what you're gonna get here, and then you can see that these two can cancel out each other, so which is gonna give you vo over v in equal to 1 plus rcs. That's what you're gonna get there. And then once you get this equation, this is what you're gonna get for your transfer function, if I'm not mistaken. Okay, and you have also the option, if you want to further down or modify it. Okay, it should depend on you, and this is what you get from this equation. Sorry, I think I made a mistake here. Let me show you. This one is R2. This one is R2, and this one is R1. So meaning at this level, this one is from R1, and this one is R2. So what we get here, we call it R2, and this one is R1. So I'm not gonna cancel out these two. Okay, it's going to remain, it's gonna be something like this: negative R2 R1 1 plus R2 CS. This is what we're gonna get into this final equation. Okay, and if I have to write it correctly, it's gonna be something like this: negative R2 R1. So it's gonna be like you multiply what you see inside here. So R is going to multiply everything that you see inside here. So that's what we're going to multiply here. Okay, so it's gonna give us this R1, R2, CS. Okay, so this is what you're gonna get for V out for this question. And remember, since I change this side with R2, so meaning all of these R that you see here, it's R2. So what you see, it's R2. Since I took it separately, so then I can solve it this side on its own. So that's what you call, you see, we call it R2. Okay, and this one also is R2. So we got this one. This is what we got, and then we place it back. We replace this one, okay, because this one is what we have this idea. So we solve this one, we got this one. So since we got this one, we have replace it here, and then continue solving the rest of the equation. And there's this one is R1. So this one is R1, and this others this one is R2. Okay, so this is how we were able to get this V out question, the transfer function. And then if you want to solve for V out, you can just solve from this transfer function for V out. Okay, and what you're going to get for V out, you have something like this: V out in S domain. Okay, remember, everything here is just in S domain. All of this just in S domain. If I have to specify, this is S domain. So V out will be equal to the final equation times V in. So it's going to be negative R2 R1 plus R1 R2 CS times V in. Okay, this is what we get into our V out in S domain. Before you get your partial fractions, then you can get the inverse Laplace. So this is what you can actually do to get V out from this transfer function. So this is what we did for this question in order to solve it. And so we had to do all of this. Okay, so there we go.